Hi, today I'm going to talk about the Lake Superior Streams Data Viewer and some of the features that make it useful. To demonstrate where this viewer might be useful, let us take the perspective of an Area of Concern manager looking to delist a threatened watershed. Areas of concern are geographic areas within the Great Lakes Basin that show severe environmental degradation. These locations are characterized by beneficial use impairments, which are changes in the physical, chemical, or biological integrity of the water. To delist an area of concern, these impairments must be resolved. Now let's return to our original goal. Let's suppose we are the manager of the St. Louis River Area of Concern, based out of Duluth, Minnesota. In our watershed, 9 out of 14 beneficial use impairments are identified, with one such impairment being the degradation of fish and wildlife populations. One of the populations which we wish to rehabilitate is the brook trout population. Brook trout, like other cold water fish, are highly sensitive to changing river conditions. This makes them an important indicator species for stream health. Along these lines, dissolved oxygen levels must be relatively high and water temperature must be relatively low for brook trout to thrive. For these reasons, the Lake Superior Streams Data Viewer will be a useful tool for us as Area of Concern managers. It allows us to perform detailed analyses on current and historical stream health and conditions. It also aids in policy decisions, since positive and negative human impacts will be reflected in the data. To demonstrate this, let's take a look at some historical data from the St. Louis River. Wearing our Area of Concern managerial hats, we're looking for patterns in the past that may better inform our future decisions. We start by clicking St. Louis River Historical Sites. We then click Site over many dates, since we wish to analyze trends over time. What we see now is a mixture of color maps, line graphs, and bar graphs representing stream attributes over a 16-year period starting in 1973. To simplify and clarify, let's adjust the time span to 2 years. The background colors represent dissolved oxygen, with green equating to high dissolved oxygen, and brown and black representing a hypoxic or anoxic environment. Fish cannot tolerate an anoxic environment, so a shift from browns and blacks to greens is a desirable outcome in the area of concern. Specifically, let's watch what happens when a new sewage treatment plant known as WLSSD opens in 1978. With the opening of the treatment plant comes a dramatic increase in dissolved oxygen levels and a significant decrease in summer water temperature. This is a trend that has continued into the present. Specifically, this pattern meant dramatically better fish survival rates since they thrive in a cold, oxygenated environment, conditions that the St. Louis River was now more likely to meet. If we look at this stretch of time pre-treatment plant construction, we see that dissolved oxygen levels are extremely low during the summer and that water temperature hovers in the high 70s. Fast forward a few years, when the treatment plant is operational, and we see a smaller summer temperature spike and year-round acceptable dissolved oxygen levels. In short, Area of Concern managers can use the Lake Superior Streams Data Viewer as an analysis tool. In this case, the construction of the sewage treatment plant resulted in a dramatic demonstrated improvement in water quality, and thus fish and wildlife populations in the St. Louis River. Thank you for watching this presentation of the Lake Superior Streams Data Viewer.